Hi, today we're going to talk about the power rule of exponents, or the power exponent rule. Our goal is I can simplify exponents using the power rule. Feel free to pause the video at any time if I'm going too fast, or if you need more time to write or think. So we already know that x to the power of 5 means x times x times x times x times x. So I'll go ahead and write that down. X times x times x times x times x. And I wrote the letter x 5 times. Well, now this exponent means, hey, you need to do this a total of 2 times. So here's my first one. And let's do it a second time. 1, 2, 3, 4, 5. Okay? Now I put parentheses around this first group and the second group. But the invisible operation here is just multiply, same as in between all of these things. So the parentheses are actually not necessary because they just mean multiply all these x's times all these x's. So really we have 5 x's here, 1, 2, 3, 4, 5, and 5 x's here, 1, 2, 3, 4, 5. So what does it simplify to? X to the power of 5 plus 5 is 10. So x to the power of 10 is what we have for x to the power of 5 to the power of 2. Well, what's a faster way we could have done it? We know the answer is x to the power of 10. Well, how can I use the numbers 5 and 2 to get 10? Multiply. So the trick, or the quick version, is to multiply the exponents. So when the base is the same, multiply the exponents. Okay? Now, when the base is the same, you'll notice that there's only one base here. So really, as long as we have a power to another power, then you're just going to multiply them together. So we can actually just cross that out when the base is the same because there's only the one base. So let's go ahead and look at some examples. X to the third to the fifth power means x times x times x. We have that x to the third. We have this 5 times. So 3, 6, 9, 12, 15. Which means if we wanted to write the whole thing out, we could. It'd be x 15, x times x times x, the letter x 15 times. So the quicker method is to multiply the 3 times 5 to get 15. So here, 2 to the power, or 7 to the power of 2 to the power of 4. Well, that means we have 7 to the power of 2. We have that 4 times, so that's less. I guess I could write that out. 7 to the power of 2, we have that 4 times. So here's my first one, then my second one, and then my third one, and then my fourth one. So how many times do I have the number 7? 1, 2, 3, 4, 5, 6, 7, 8. 7 to the power of 8. The quicker method is to just multiply. 2 times 4 also gives you 8. But the reason I still show you the long method is if maybe you forget or you get mixed up with the different strategies, add, subtract, multiply, well, you can still always write it out and just count how many of the base is left over. All right, so again, we're going to multiply 8 times 0. Well, 8 times 0 is 0. And we learned already that anything to the 0 power just equals the number 1. So there we go. We used a couple of rules this time. Okay, 6, so y to the power of 6 to the power of negative 3. Multiply those two together. 6 times negative 3 is negative 18. Well, we always want to simplify to a positive exponent. So we learned the negative rule, which is cross the line and change the sign. That means we take just our base and our exponent, move it to the bottom of the fraction. Okay, so that'd be y, and then, so that was cross the line. Change the sign means make it a positive 18. So y to the positive 18, well, because we moved this down here, there's nothing up there. We always have that invisible 1. So 1 over y to the power of 18. Okay, now here's a tricky one, and in the next slide we'll talk more about tricky stuff. But here we have 2 times x to the third, all of this to the fifth power. Let me show you what that means. That means we have 2 times x to the third 5 times. So 2 times x to the third, and here's our first one. Here's our second one. Here's our third one. Here's our fourth one. And here's our fifth one. Yeah, that's supposed to be x to the power of 3, all of those, those little 3's. Okay, so these are all being multiplied together, that invisible multiplication sign. And multiplication, we have the commutative property of multiplication. All that means is we're allowed to move things around. So I'm allowed to move all these 2's next to each other. 2 times 2 times 2 times 2 times 2. And I put all those in front. And then I'll put those x to the thirds in back. 1, 2, 3, 4, 5 in the back. And now we can simplify them. Well, how many 2's are there? 1, 2, 3, 4, 5. So 2 to the 5th power times. Now how many x's? Well, we have learned that if things are being multiplied, you can add the exponents. 3, 6, 9, 12, 15. So there's a total of 15 x's. And then the very last step to simplify is when we have a coefficient. So notice that the base is over here. That's the coefficient. Let's just turn that into an actual number. So 2 to the 5th is 32. So we've got 32 times x to the power of 15. Now that was the long process. Kind of quicker would be almost to look at this as 2 problems. 2 to the 5th and x to the 3rd to the 5th. So then you can do your 2 to the 5th as 32. And then we can do our trick. 3 times 5 gets you your 15. And just keep in mind that the base is the variable or number that the exponent is attached to. And then this, if there's a number in front, that's called the coefficient. Okay, now our last one, don't get tricked. That one we just practiced, our last example, that's going to be one of the trickiest things you see. So let's practice just some basics and then some tricky stuff. So we could have like x to the power of 4, all of that to the power of 9. Well, we could write that out, but that would be so much writing. So remember, x to the 4 to the 9th, a power to a power. We're going to use our trick, multiply those together. What is 4 times 9? 4 times 9 is 9 plus 9 is 18. So 4 times 9 I think is 36. But check it on your calculator just to be sure. So there we go, we've simplified that. What if we had, ooh, here's one we didn't see in their examples. What if we had something like this? 5 parentheses, x squared to the power of 3. Well, notice how this 5, it's not in the parentheses, it doesn't have an exponent, it's just there. So it stays as a 5. It's almost like separating this into 2 problems. Then we've got our x squared to the power of 3. We can multiply those to get x to the power of 6. Let me show you how that is different from what we did in on the last slide. On that last slide, we have that coefficient inside the parentheses. So because it's inside the parentheses, this 3 also applies to the 5. So 5 to the power of 3, so that means 5 times 5 times 5, I think is 125. But always check it on your calculator. Okay? And then also we have the x squared to the power of 3. So 2 times 3 is 6. So see how, based on where the parentheses are, that changed the question. Oh, here's another really good one. Negatives. So let's say we have something like this. Negative x to the 5th, all of this to the 4th. Okay? Well, this means the negative is outside, chilling by itself. Leave it alone. And then we just have 5 times 4 is 20, so x to the power of 20. Whereas if we had it inside the parentheses, well, that's an invisible 1. So we have to do that 4 exponent on the negative 1. So that'd be like negative 1 times negative 1 times negative 1 times negative 1, which is a positive 1. And then we still do 5 times 4 is 20 for the x. So we end up with a positive x to the 20. So there are some things you could get tricked on. Feel free to go back, pause, rewind as needed. You got this.